I'm Anil Kumar sharing with you the test problems, and in my videos you'll also learn different ways of answering the same question. This question is on polynomial equations. It says state the equation of three different polynomial functions that have roots of 3, 1 and -2. Sketch any one of them. So I've purposely modified this question, and I want to give you three different polynomial functions that have roots of 3, 1 and -2, and we'll sketch at least one of them, right? So when we say that the roots are at x equals to 3, x equals to 1 and x equals to -2, that means if we write in factored form, then the factor for the polynomial should be x minus 3 times x minus 1 times x plus 2, right? So that will give us roots at the given points, and we say polynomial is p of x equals to this. So that becomes one of the most simplest equations which you should write in your test paper, right? Now three different forms. So another thing which you've learned is that you could also write this as a times any of those, right? So let us say we write 2 times x minus 3, x minus 1 and x plus 2. So if I give you y-intercept, you can always find a, right, and then get your equation. So that is how normally you do to find equation from a graph. Now there are so many other ways of doing it, and this is what I like most. Now you have this equation, and these are actually zeros, linear zeros, right? Since we know the roots, right, we can define zeros of different kind. We can say, well, this is my 0 which is of order 2 or multiplicity 2, and this 0 is of multiplicity 3, for example, correct? So I can also give an equation in this particular form, right? So I hope you appreciate this idea, right? Now to sketch, I could have sketched any one of these, but I'll prefer to sketch the last one for you. So what we will do is we'll see how to sketch it so that we learn some more from this test problem. It's an excellent question. Now, if I see the degree of the third equation, so I'm trying to sketch the third one for you. The degree is 1 plus 3, 4 plus 2, 6. So it is even degree. So we are sketching even degree. And leading coefficient is positive, right? Positive leading coefficient, let me write a of n, right? So positive leading coefficient means right side up, even degree means both same sides. Zeros are at plus 3, plus 1 and -2. So let us say this is -2 for us, then this is plus 1, and this is, let us say, plus 3 for us. Now in a different ink I'll show you how the zeros should be. Now this one is the linear 0 at -2, so it will go straight. So in behavior, you know, we are coming from this side. Then the next one is at 1, which is cubic. So cubic actually goes kind of like this. Do you see? It flattens out, it never turns. Flattens out, then move on. And the last one is at plus 3, which is of order 2, multiplicity 2, you can say. So it should turn like this, correct? Now joining these zeros, we can actually sketch our graph. So that's easy way of sketching. Now one thing which I haven't mentioned here so far is the y-intercept. So we'll calculate the y-intercept and then write its value at the y-intercept. So that is how we should do. It's easy. So y-intercept is when x is 0. So let's calculate what is p of 0. So if I plug in 0 here, I get -3 square, which is 9. And this is 0 here gives me 1. And that gives me 2, correct? So 18. So 18 is, I'm sorry, this is -1. This is -1. That is what I was thinking about. So we have this point, and this point should be equal to -18. This is kind of a check for you also. We had nearly made a mistake, right? So it's kind of a check whether the graph is true or not. Always find y-intercept and then sketch a neat graph, right? So this should be a very smooth curve without any breaks. I've purposely shown you in different things to appreciate how the graph behaves near a zero. I should say near the x-intercept. Since the zeros have different multiplicities, the behavior of the graph, which depends on the multiplicity of zero, is very unique, right? So if it is linear, it goes straight. If it is cubic, it kind of turns and then move forward. And in case of a quadratic or a even zero, even degree zero, or even multiplicity zero, it bounces back like a parabola. I hope that helps you to understand and do well in your test. Thank you and all the best.